What's up, everyone, and welcome to the Amateur Coder. As you can see by the YouTube banner, this is going to be all about exploring, innovating, and sharing. These are three values that I've taken away while learning technology. It's all about exploring new ideas, innovating new processes, or innovating current processes, and sharing the works so that for criticism, feedback, comments, someone might be able to take this idea or project and take it to the moon. They might be able to maximize its potential. And technology is meant to make life easier for all of us. It's meant to be shared and used by everyone and make everyone's life easier. So that's the main goal of technology. So we will be... A lot of this channel is going to be about, a lot of the work is going to be creating models, software, trying to get good at it, good at deploying it, making it efficient, reusable, and we will also be working on testing or developing a hypothesis and testing it, as well as making visualizations, just anything we could do with technology. It's not going to be smooth. There's going to be a lot of trial and error. It's going to be a lot of learning. Like the channel's name is, it's called the Amateur Coder for a reason. So this is a great channel if you're someone who is looking to sharpen your coding skills, do projects, hit the subscribe button, and let's work together. Let's collaborate and let's improve. So if you've never worked in Python before, that's fine. We're going to explain this from the base. If you look at these first two lines, they have two keywords that are similar. So import NumPy as NP from sklearn linear model import linear regression. So they both have the word import, and that word import it's a different color than NumPy, NP, sklearn, linear regression. So anytime you see that different color on a Python IDE, it usually means that this is a keyword. In our case, import means to, if you're familiar with the English language, import means to bring in, right? And export means to bring out. So someone has to be exporting something if we're importing it. So what this is Python has a library where if you make an algorithm, let's say you make an algorithm that you want to share, you could export it, wrap it up, and then it gets sent to a Python library. From that library, anyone could use it. So import, as we know, is to bring in. What we are doing is we're bringing in, just like a real library, we're taking a book. We'll call this a cookbook. Python's library is filled with cookbooks, and these cookbooks are filled with recipes to get things done. The recipe or cookbook that we're bringing in is NumPy, and this one is sklearn. So NumPy and sklearn are our two cookbooks, and we're going to use these, or we're going to use recipes in this cookbook. So this one is linear regression. That's going to be the recipe that we're using. For NumPy, we're going to be using array. So you can see our recipes are in blue. So what these libraries or cookbooks are, or recipes are, they're algorithms. If you've heard of the word algorithm before, that's awesome. If you haven't, an algorithm is a list of steps to accomplish a goal. So a common algorithm that is always used as the simple example is making a peanut butter and jelly sandwich. A list of steps to make a peanut butter and jelly sandwich. So if you were to take those steps and put it into Python, then that would be a function. It would be called a function. From there, you could wrap that function or export it, deploy it, so that people could use it. So here, back to what we were saying, array and linear regression. So these are our recipes. Those recipes are really algorithms. They're a list of steps to accomplish something, accomplish a goal. So we will go to X and Y. So what x is x is equal to np.array. If you're not familiar with an array, what an array is array could be classified as a vector or a matrix. So a vector is 1D. So a vector is a straight line. It has a direction and a magnitude. A matrix is 2D, 3-dimensional, 4-dimensional. There's levels to it. So you can think of a matrix as a Google sheet, a Microsoft Excel worksheet, something with columns and rows. It has multiple dimensions, right? So it has two columns, 2 rows, 3 columns, 3 rows. So that is a matrix. So what we're going to be doing here is we're going to be making a matrix and a vector using NP or NumPy's array function. So we will I'm just going to redo this just for the practice. Let's do np.array. Actually, you know what, I'm going to be humble. We're going to remove this, or let's get this completely. I want to get my practice in too, you know, so I don't want to just look at this or just practice. Look at this or just copy. I'd rather just, so this is going to be called the NHL prediction model. So I like to use the NHL standings as a way to teach. Oh man, I originally wanted to talk about Cramer's rule. I don't know how we ended up here, but we'll go into that later. That'll be the next video. We're going to just do this as an introduction to machine learning. NHL standings. If you like the NFL, I don't know if anyone. So here what we have is wins, losses, OT. OT is just tie. I'm not a huge hockey fan, so I love, if you saw there, I had read it up. I love the Jets and the Knicks, but yeah, hockey, I'm from Long Island, so love the Islanders. Let's go Islanders. But yeah, I don't really know that's irrelevant. So they have a point system. That's what I like. This is good for a machine learning model. Let me get, so import, we'll put down what we already know. Import NumPy as MP, import sklearn dot linear model, and from sklearn dot linear model, import linear regression. Awesome. So you could also do this like this if you like, from NumPy import array. So we're not gonna, it's just pretty conventional to do it this way, but sklearn has a bunch of functions, so sometimes you're using pre-processing, trains, test split. There's just a bunch that to use. So NumPy, it's not there's like you calculate determinants, you do a lot of array map. So back to what we were talking about. Let's do x. So x equals let's get this. I'm gonna just put this on my other screen for now, just to get these. So x, we're gonna have, or let's just talk about what x is real quick. So if you've taken math before, you probably have heard of this equation: y equals mx plus b. Y is an answer, right? We know that that's an answer. Well, y is known as a dependent variable. So if you're new to this, just think dependent, because this x is our independent variable. So x is independent of y's value, but y is not independent of x's value. Y relies on x. If you've seen this equation before, it's probably in math class in high school, college, wherever. Sometimes kids learn it too. Y equals mx, they learn. So yeah, what y is a value we are trying to predict or calculate, right? It's f of x. So we have a function, we're given a function, and we're just trying to find the value. X is an input value, or what we know or are given to find y. So let's say that we could, in our case, we're going to be using wins, losses, and ties to predict points, right? This is already a system that we already know. It's a linear system, so that's why it's gonna be so smooth. It's gonna work. That's why I really like the standings. But yeah, so if we want to solve a linear system, let's say you are a engineer in a water department. There's each water, or yeah, each water the water quality depends on chemicals that you put into the water, right? The system. So what you want to do is, you have y, which is it's a number that you predetermined, right? And you're trying to reach that by calibrating the rest of the chemicals to be a certain value, so that water reaches that balance level of being clean. So maybe you have ammonia and fluoride, chlorine, and you're putting that in the water. Then you have three x's, right? You have y equals mx1 plus mx2 plus mx3 plus b. So x1 is just the input value that we're given. We will go, let's go, m is the slope, or rate of change / speed. So let's say a car moves at 30 miles per hour, right? So x would be hours, m would be the rate of change. So we go 2 hours and our car goes 30 miles an hour, we're going 60 miles, because 2 times 30 equals 60, right? So 60 would now be our y. So all m is if you were to add 1 unit of something, how much would y change? M is the predictor. X, it describes the relationship between x and y, and how much y changes when x changes. So m is, I like that. M is our predictor. It shows how much y changes with x. Let me just make these variables constant. Alright, and we got b. So b, talking about constant, perfect. B is our constant. So if x is 0, then we gotta have if x is 0, then m times x is equal to 0, right? Then m times x is 0. So what this means is that y equals b. So y equals b. So all this is saying is that b is y when y is 0. Awesome. So we're going to start with a numpy. Let's go np.array. We got our numpy. So to use the function, to call the function, you're going to be using parentheses. If you've never used Python before, parentheses is an easy way to differentiate between a variable and a function. So I like to usually say just a variable has an equal sign next to it and a function has a parentheses. So what we have is numpy.array. We're going to go, let's make our list of numbers. So I'm going to bring this back in here and we're going to kind of scroll this up. Alright, I can't. So awesome. So we're going to take the results for a bunch of teams. Let's close this guy. And we got x equals np.array. So we got x equals np.array. We're going to create our array. Let's get to it. We're going to have, I'm just going to, array is wins, losses, OT. So this is going to be the format array. So we're going to have 52, 26, and 4. We will put the name of the we're going to put the acronym, the team's acronym right after. So the brackets are used to make a list in Python. So brackets are used to make a list in Python. If you don't know what a list is a collection of objects or things. So in Python, it's a collection of objects. We're collecting data in our list. And an array is just a collection of lists, right? It's a bunch of a series of objects, just one stacked on top of each other. So we will add our second list or the second team in. So if you were to, this is kind of like an Excel sheet. So it's going to look like this. 52, 26, 4. Then we got our next team is going to be 47, 27, 8. So that's how it works. It's like an Excel sheet, and we got our wins, losses, OT. It's just rows and columns. That's all it is. 27 and 8. Next, we'll do Florida. Tampa Bay Lightning was the last team, and this will be Florida. The Florida Panthers. So we got 47, 31, 4. Let's add more teams in there. Actually, we're going to keep it like this. So let's go y equals np.array. We're going to put our total points in here. So the total points, we got 108, we got 102, and we got 98. So what we have right now is we have Toronto, Tampa Bay Lightning, Florida Panthers, right? So we got this computer, or our Python script right now, knows how many wins, losses, and ties these three teams have, and how many points these three teams have based on those wins, losses, and ties. So it's going to so next we're going to do fit. So, or we got to make the model, right? Model equals linear regression. So next will be fit and then score, I'm pretty sure. So fit and then score, awesome. I wasn't sure if we were supposed to assign this to a new variable. So let's go model.fit. Let's fit our data to our equation, and then we got score. Score equals model.score, and we didn't have any. Alright, just want to make sure we didn't have any parameters to put in. X, Y score. So next, we'll go print the model dot coefficients, and let's print model dot intercept. See what. So this is going to be coefficients are M's or weights. Intercept. Let me just double check if intercept is bias. Intercept the bias. Alright, yeah, so intercept is the bias. Intercept is bias, or we'll call this bias. Is the bias. So when you get, if you work with neural networks a lot, you've probably heard of that, weights and biases. So neural networks, and if you made a model from scratch, you've definitely heard of that, weights and biases. So there's different processes to determine those. They're called, you go forward propagation, which is knowing the inputs and not knowing the outputs, and trying to just consistently recalculate those weights and biases to fit across that data to predict the output. You could also have backwards propagation, which is taking the knowing the output and then doing the process in reverse. So calculating weights and biases in order to find the input, determine the input values, and then you combine the two together, which is what a neural network is. So yeah, there's a sigmoid function. So you take those weights and biases and then you put them into a sigmoid function, and you're able to just create the model as a whole. So yeah, so just for now we're going to focus on coefficients and intercepts. I didn't mean to go on that tangent right there. Sorry if I didn't explain that well, if I confused you. That is just talking, running. Coefficients are our weights, and then intercept is the bias. Intercept is the value that's already there, right? So yeah, am I missing anything? Test arrays. Alright, print score. So we got test array and score. Print score. Let's run this. So we will, what happened here? np.array. Okay, I forgot a bracket. So, man, amateur mistake. So 1. So what the score is the score is r squared. So what that means is that let me run that again. What popped up? Anyway, the score is r squared. So what that means is the closer to 1 is a full score. Anything away from 1, like even if it's above 1 or if it's below 1, it's not as strong. So you want to get a score of 1. And what 1 means is it means the model was able to capture a lot of the noise, or be able to make a strong prediction. So You see, this is the equation. So we got wins are 1. It's saying our equation is y equals 1 times x minus 1 times losses. We'll do losses and wins. So 1 times wins minus 1 times losses, minus 4.44, we'll call that 4.44 to the negative 16th. So 444 times 10 to the negative 16th ties. So this is what it's saying the equation is right now, just for us to, it's given its, let's do r squared equals 1. Cool. So let's put in our test array. So we're going to do test array equals, we're going to put in a losing team. So we're going to do 40. Let me just double check. So 2 brackets. Do we still need 2 brackets when awesome. Test array model dot predict results equals model dot score, model dot predict, print prediction. Alright, so I'm supposed to assign this to a variable. Cool. So awesome. So these do require 2 brackets. Whew, embarrassed. So for 42, 33, 7, score is 91. That's pretty good. That's actually very good. Try to find a, what if we did 33, 39, 10. Boo, Boston. 76. Wow, alright. So this is already accurate. Nice. So what I don't like is that it's saying that the team is at 82 when they are at 0, right? So B is equal to 82. So this is what the equation is. So what if we were to, see, that's weird. How did this, maybe this is not, why do I need a bracket? 2 brackets down here, but now 1. So vector matrix. I'm trying to think. So I guess if you want Alright, so for vector you only need one bracket. For matrix you need two. Let's remember that. We're gonna write that down. Vectors only need one bracket. Matrix needs two. Alright. Honestly, I'm satisfied with this model. It has, let's go 56. Let's see how it does with the team that's winning a little bit more. $116. Alright, yes, this model is pretty nice. Cool, so we just remade this. This is something I did a few months ago. I really wasn't prepared to even, I had it open, but I really wasn't prepared to share it. I didn't really look it over or nothing. It was just more so just wanted to practice. I haven't done made a model in a while. I've been focusing on Tableau and data analytics. I've been doing a lot of statistics. So yeah, I've been away from sklearn for a bit. SciPy, I've been working with SciPy, Tableau, NASA data, nighttime lights. So just trying to do something that's a little different. So it feels good to just be able to come back and recognize a lot of the stuff. This tripped me up mainly because I usually import my data through pandas and I don't create arrays from scratch. But yeah, awesome. So we will, if you'd like to put more data in this, all you have to do is add a comma after your last comma brackets after your last entry, and then you could put, we'll add the Islanders 35 35 12. Let's add another 34 36 12. $33, $39, $10. $33, $39, $10. Awesome. Let's add 82. You got 82 in there. 80. Cool. Let me just double check all of this, make sure it's 35, 34, 33, 80, 82, 76. Awesome. We got 56, 116. Perfect. So we're going to save this. We will move this out the way. Yeah, we'll just call that a video. I'll make a separate video for what we're gonna do next, just because it's a more complex topic. I wasn't planning on making this video on machine learning. It was just on my screen. I had it open, so I like what we did though. It was fun. So yeah, thank you for watching. If you enjoyed the video, hit subscribe. Otherwise, I will catch you guys in the next one. See ya.